All right, good morning, everybody. Looks like we are live, and I'm hoping that you guys are checking in. I'm going to give it a moment for everyone to get caught up to the stream, of course, with the delay and everything we keep talking about. So it looks like at the moment it is me and two people. So if you're here, give me a little comment, checking in so I know who I'm talking to. And we will start today by going over this this paper here that I put on the Google Classroom. We'll be doing a couple of these. I don't want to spend the whole time doing this whole sheet, but every question there can benefit from these tips that we talked about yesterday. All right. You don't always have to use all of these tips in each question. Sometimes you don't need any of these, and it just falls together very easily. But this is something that comes with practice. You can't expect to know how to balance equations without actually practicing them over and over and over. And for some of you, that might mean, 2-3 dozen and you're good. Others, that might mean you have to do a couple hundred in order to be comfortable with this. So everybody's going to be on a different, level of understanding, at least at first. And we have to get everybody up to speed. If you're not quite sure what's going on, you need to keep practicing. So that's why I gave you this worksheet with 37 questions. There's a good amount there. It should be enough to at least get everybody rolling. Okay, now, having said that, today we are going to start by going over that worksheet, do a couple there. And then after that, we will start bringing in the idea of the reaction types. And this video will probably be about a half hour to 40 minutes long, depending on what it takes to get through those two topics. But I do need to set up for my next class as well. So with that in mind, let's go right to the worksheet. And again, if you guys are watching, please give me a comment on the chat to let me know who's watching and who I'm talking to, okay? And if you have any questions along the way, go for it. Just ask in the comment section. We'll see what we come up with. I'm a little froggy this morning. I didn't sleep all that well. For whatever reason, with everything that's going on, I'm actually sleeping a lot worse than I was before. It's weird. Whatever. That's a whole nother topic. Anyway, let's go into okay, I got a couple people checking in. Very good. Let's go right to the worksheet, and we'll do number one. Now, I was just looking at number one. Number one can benefit from one of those tips. Okay, so let's look at those tips again. You got the tip right here. All right, the first one says if you're stuck, start over all your work with a 2 out in front of the first thing. Okay, the second tip, balance the polyatomics as one thing. So in this question, there's a phosphate, and you're going to balance the phosphates, not the phosphoruses and the oxygen separate. I'll show you what I mean. And then the last tip, we're actually going to use this one as well. So every so often, it doesn't happen every time, but when you have a water, sometimes it helps you to balance it if you rewrite it as HOH, because then you can balance the hydroxides as one of the polyatomics. So let's take a look at these and see what we got. All right, the very first one, I'm going to see if I can zoom in. Just kind of ad-libbing the lesson here for a moment. That's a little better, I think. Okay, easier to see. So I'm going to get a blank piece of paper because I'm going to make some notes here, and hopefully you guys are following along as we go. So number one, okay, I'm going to just rewrite it so you can see it a little bigger. The first one is, let's get a pen. Where's my pen at? Just had a pen here a minute ago. It's like I'm still in school. All right, it was actually on the floor. I have no explanation for that. So anyway, let's look at this. So I got H3PO4 plus KOH. And that's going to produce, normally it's all one line, but I'm going to write the products down here so I can write it a little bigger and it'll be easier for you to see. But since I zoomed in, that's what I'm going to be left doing. It's going to make K3PO4, which is potassium phosphate, and water. Now, you can try and balance it with the H2O as it's written, but I'm going to go ahead and rewrite it as HOH. On the worksheet, if you just cross that out and write HOH next to it, that will probably get you through the same idea. Now, the reason why I wrote it as HOH here is because I have now a hydroxide on each side, and you can balance them as a thing, just like you can with the phosphate. So I have one phosphate and one phosphate. That's already taken care of. So let's look at the weird stuff, okay? we have 3 hydrogens, right? A lot of people are going to want to include this hydrogen there, but since I did the HOH, I'm going to do the hydroxide. So all you really got to worry about is H3, or 3 H's. Down here, I only have 1 H. So let me put a 3 there. Now that gives me 3 hydroxides, doesn't it? I'm going to come up here and put a 3 to give me 3 hydroxides. And when I did that, I actually fixed my potassiums as well. 3 potassiums, 3 potassiums. So that's that. What's up, Connor? So we just did the first one, right? Writing out as HOH really speeds things up in some cases. Not all the time, but it does help when it needs to. Let's go to the second one, all right? The second one is K plus B2O3, and that makes K2O plus B. All right, this one shouldn't be too bad. Now, I did get an email from somebody saying that this worksheet's a little confusing because of the dashes. The dashes are where you put your answers. That's all it is. So remember yesterday we were talking about the coefficients, and you just say, like in this previous one, we had an answer 1, 3, 1, 3. 1, 3, 1, 3. So that's what you put on the dashes. So anyway, this is the question we're working on now. Let's say we... Oh, here's another tip. Okay, add this to your list. This just occurred to me. All right, tip number 4. You ready? If you have something alone, do that one last. Okay, so this is going to be worded in a weird way. If you have something that's completely by itself, do that one last. So, you ready? Do the thing that's alone last. So say that one for the very, very last thing you balance. Okay, so now you have 4 tips. I thought I forgot one, but you see them as you go anyway. So looking at this question, we have potassium that's by himself, and we have boron that's by himself. So you have a choice. We can either do potassium last or boron last, but regardless, we should do oxygen first. So it looks like I have 3 oxygens here and only 1 there. So I'm going to put a 3 here in front of the K2O, fix my oxygens. Now it's very straightforward to fix your potassiums. Put a 6, and then your borons, put a 2. Done. So you could have struggled with that if it wasn't for that last tip. Do the thing by itself last. All right, I hope that's starting to make sense. All right, I'm going to go to number 3, and I'm going to rewrite that real quick onto this paper. I got HCl, and of course it's off camera, what doesn't fit, plus NaOH, and that's going to make sodium chloride and water. I'm going to rewrite the water as HOH, and here's what I got to start with. This is number 3, okay? I rewrote the water as HOH because I had a hydroxide over here. So now I have a hydroxide and a hydroxide. Now, if you add everything up, I got 1H, 1H, 1 chlorine, 1 chlorine, 1 sodium, 1 sodium, 1 hydroxide, 1 hydroxide. And I just went through everything. This is already balanced. This happens from time to time where you don't have to do anything and your answers are just 1, 1, 1, 1, whatever. Okay? So that was a more straightforward one. You might have gotten stuck in trying to solve for an answer if you left it as H2O. That's one of the pitfalls of this thing. All right, the very next question, we're looking at number 4. I'm going to rewrite it here. Sodium plus sodium nitrate makes sodium oxide plus nitrogen. Okay? This is number 4. So we got some goofy stuff going on here. I don't have any polyatomics that are the same on both sides, meaning I do have a nitrate here, but there's no nitrate as a product, so I can't balance it as nitrate. I'm going to have to do it as nitrogen and oxygen as separate things. Moving on, I do have sodium that's completely by himself, so I'm going to do that one last. I could do nitrogen last, but the 2 might complicate things. So here's how I'm going to do this. Save sodium to the end. I'll do nitrogen second to last, and that just leaves me with oxygen here. Did I write that right? Yeah. So I'm going to do oxygen first. So I have 3 oxygens here, and I have 1 oxygen there. So I'm going to put a 3 out here. Okay, I hope that makes sense. So put a 3 there. Now, that gives me 6 oxygens. Okay? Or, I'm sorry, 6 sodiums. Okay? So my oxygens are good. I got 3, and I got 3. Now, let's do nitrogens next. It looks like I have 2 here. Okay? So I'm going to put a 2 here. Now I ran into an issue. Okay? I should be doing this in pencil so I can go back and make corrections. But anyway, this gives me 6 oxygens. I only have 3 over here, so I need to double this. So I'm going to scratch out that 3, and I'm going to put a 6. You're just kind of going element by element, making sure it's all correct. So let's again check from the top. I have 6 oxygens and 6 oxygens. I also have 2 nitrogens and 2 nitrogens. Last thing I got to fix is my sodiums. Here on the product side, I have 12 sodiums. Sorry about that train. I don't know if you guys can hear that, but there's a train, railroad tracks not far from my house, and it is quite annoying. Anyway, I have 12 sodiums. Up here, I already have 2 accounted for. So I only need 10 more. So I'm going to put a 10 here. That one was a little tricky, okay? Let's go back and double check everything from the top, make sure we're good. I have 10 sodiums there, but I have another 2, so that's 12. This gives me 12 sodiums right there. All right, sodiums are good. Then I have 2 nitrogens, and I have 2 nitrogens. Very good. For oxygens, I have 6, and then I have 6. So we're all set. That's how you balance that one. Now, there is one step in balancing that I haven't told you yet, okay? And that's the last step. That's it. If you can reduce everything, you have to reduce it, okay? So sometimes when you go to do this and you're going to get answers like, I don't know, I'll just make this up, 2, 4, 6, and 2. If you get something like that, you got to reduce everything to 1, 2, 3, 1, okay? This would be the correct answer for your balanced equation. You have to bring all your coefficients to the lowest whole number ratio. That's the proper answer. Okay? All right, let's do a couple more, and maybe we come across something like that. We did 4 of them so far. Let's do like 10 of them maybe. Yeah, let's do like 6 so we can actually get on with the new stuff today. So number 5 is going to be carbon plus S8 makes CS2. This one shouldn't be too bad. Do carbon last because it's by itself. That means you do sulfur first. Sulfur's got 8. I got 2 over here. Put a 2. That gives me 8. Now I have 4 carbons. 4 carbons. Done. All right, you guys that are watching, you got to give me some sort of feedback here. I got 5 people checked in. A couple people have said hi. Just let me know that has made sense up until now. I'll probably do up to number 6. So this should be our last one coming up, all right? Number 6. That's correct. If it reduces to a number 1, you don't have to write 1. 1 is understood. But you have to have all the other coefficients in there if it's different than 1. All right, Connor, hope that helped. All right, let's do number 6. Number 6 should go pretty easily. Sodium plus oxygen makes sodium oxide. Okay? That's number 6 we're doing right now. I'm going to do sodium last because it's completely by itself. One could argue that oxygen is also by himself, but the 2 here might complicate things. So I'm going to do sodium last and do oxygen first. Okay? 2 oxygens, I'm going to put a 2 here. That gives me 4 sodiums. Pour 4 there. Done. This balancing stuff should start to come very quickly to you after seeing all those. And if you tried them on your own, hopefully it worked. Okay? Let's move on to talking about the 5 types of reactions. Okay, so this is new stuff. Okay? I'm going to just do some notes right here on this paper here. I'll just move it down. All right? Jeez, I'm wrecking the joint over here. All right, so there are 5 types. 5 types of reactions. Now, every so often you might see that abbreviation, RXN. Okay? Thanks, guys. All right, JT Go Crazy. Who is that? Help me out here. Who are you? I know C202 is Connor. Everybody else seems to be using their actual names, which is thankful, because I'm a dope when it comes to names anyway. All right, so let me know who you are. JT Go Crazy. Next, let's look at the 5 types, all right? I'm just going to list them, and then we'll start getting into some details. Josiah, did you log out and log back in as somebody else? What's going on there? Anyway. All right, number 1. There is a combination reaction. Okay, you're going to want to follow along and write these down as well. The second type is a combustion. It's all good, dude. Whatever account you got, I don't care. You're just following along is all I ask. So you're doing what you need to do. The third type is going to be a decomposition. Fourth is a single replacement. You might see that called single displacement if you get into a worksheet that I'm probably going to give you soon. Or if you start doing your own internet research, you might see it called single displacement. Same thing, just different name. The fifth and last one is a double replacement. All right, so from the top, you got 5 reaction types: combination, combustion, decomposition, single replacement, and double replacement. Now, there might be like some nicknames that I go with for these. So combination, I'm going to probably start referring to as a combo. Okay, combination, combo. Combustion is just combustion, whatever. Decomposition, I might refer to as decomp. So decomposition would be called decomp most of the time. And then single replacement and double replacements, I'll just call singles and doubles. Okay, so these are the technical names that we'll be living with, but I might refer to them in problems with their shortened names just to speed things up. Okay, so that's that. Now I'm going to give you some notes for these. Okay, you're going to follow along, and by the end of class today, well, that's really weird to say. By the end of this video, I'm going to have you identifying reaction types from that worksheet. So we'll go back and we'll do the first 6 or so again, but deciding what kind they are. All right, so this is very, very critical that you're able to define and decide what kind of reaction you're looking at, because that will allow you to do more things in the future when we try to do more new heavy-duty stuff. So here's, let's get this in here, because I want to let you know I'm still here. All right, let's turn that off, and we'll go to this thing. So I'm still here, everybody. Okay. Anyway, let's look at a combination reaction, okay? Here's an extension of that. A combination reaction is always when you have 2 reactants and it becomes one product. 2 become 1, okay? So if you see that right away, it's a combo reaction. And again, all I need you to do is be able to tell me what kind it is at the moment. Soon you'll be taking this pattern and extending it to decide to decide what kind of products you get. So for now, you're just getting the products given to you. Combustion reaction is always something plus O2. At the moment, I don't care what the products are, but it's going to be something plus O2. All right? Your decomposition reaction is going to be 1 reactant, and it breaks down into 2 products. All right? It's basically breaking down. It's decomposing. That's why we call it a decomposition. Single and doubles get a bit more complicated, okay? This is always going to be, I might have to slide this over here. So we're talking about singles. It's always going to be a metal plus an ionic compound. Those are the reactants, and that's all you need to identify what kind of reaction we're talking about. A metal plus an ionic compound. For a double, the last one, similar, but it's an ionic compound plus an ionic compound. And again, you don't need to worry about what the products are or how I figure that out just yet. That will come in time. Probably by the middle of next week, you'll be doing a lot of the predicting on your own. Anyway, these are the 5 types. with the notes. So from the top, you got your combos. That is when you have two reactants and they become one product. A combustion is anything reacting with O2. Now, O2 must be a reactant for this to count. If you got O2 as a product, it's probably something else, okay? It must be on the left-hand side of the arrow for it to be a combustion. And it must be by itself. So something, whatever that is, plus oxygen, okay? A decomp is basically the opposite of a combination. It's when you have one reactant and it makes two products. So my name is combustion. Combo? Connor? You're confusing me. Anyway, number 4, singles is when you have any metal by itself plus any ionic compound. All right? And a double is 2 ionic compounds together. All right? This is the bare minimum that you need in order to decide what kind of reaction it is, at least at this point. So with those notes, if you guys need to pause the video or something real quick, let's go to this so you can see the whole thing. All right? Hopefully, can I get it all to fit? Close. There we go. We got the whole thing in there. So if you need to pause the video real quick, and you can write all that down, okay? Connor, I still have no idea what you're trying to tell me. I see C2O2. Are you saying carbon plus O2 makes combustion? I see what you're getting at, I think, but we'll see. All right, so hopefully you got all that written down and maybe a screenshot or something that you can refer to. It's entirely up to you how you do this. But now, I get you, Connor. We'll figure it out. I'll level you up soon. Don't worry. Anyway, let's zoom back in. Let's look at these one by one. You got your worksheet there. All we're going to do, let's get this wire out of the way. All we're going to do is tell me what kind of reaction we're dealing with. Sorry about the camera there, trying to do this on the fly. So the first one, I have phosphoric acid plus potassium hydroxide. You see how important the last unit was now? And that makes potassium phosphate and dihydrogen monoxide, or water, okay? I'm going to call this one a double because it is 2 ionic compounds together. Now remember, this list, double is an ionic plus an ionic, okay? How you tell an ionic? Well, if it's got a metal. So potassium, right here, potassium is definitely a metal, and that's coming first. When you see hydrogen in front, it's acting as a metal, and therefore that's an ionic compound. Next, boron. Boron's a weird one, isn't it? Okay, let's call this one, boron's a metalloid. So you're never really going to see this type of reaction, number 2, on the quiz or the test or whatever, because I'm not going to throw metalloids at you. So because of that, let's skip to the next one. I got HCl and NaOH. That's hydrochloric acid and sodium hydroxide. Both of them are ionic, so I'm going to call that a double. So if we're keeping track, let's call the first one double. Okay. We skipped deciding what kind the second one is. You still got to balance it, but skip deciding what kind. The third one we said was a double. Okay. The fourth one, I have a metal plus an ionic compound. So what do you guys think? I'm going to go with single because it's a metal and an ionic compound. That's just the rule, single. Down here, it looks like I have, for this next one, number 5, I have carbon and sulfur makes carbon sulfide or carbon disulfide. All right. I'm going to say number 5 is a combo because 2 reactants become 1 product. You're gonna get the hang of this pretty quick. All right. Let's do number 6, and then we'll call it there. Sodium and oxygen together make 1 product, so that's another combo. All right, here's what I want you to do for, we're going to wrap this up. Okay, it was like 25 minutes. We actually got through that pretty quick. I want you to have these notes right here, okay? I want you to have these notes. So take a picture, whatever you got to do. This is the new stuff today and how you identify what the reactions are. I want you to go back to this worksheet. If you haven't finished balancing that, this time to kind it was, I want you to do that for all of these. So balance this whole worksheet and identify all of them. All right. Why wouldn't number 6 be a combustion? Number 6, okay, very good. Number 6 could also be called a combustion. That's one thing that I didn't get into that we will actually see in the future, that you can have sometimes 2 different types. Okay, so you were right that it would be called a combustion, but it's also called a combo. Same deal with number 7. Okay, this would be a combo because 2 become 1, but it would also be called a combustion because oxygen being a reactant. Very good. Thank you for pointing that out. Kind of slipped my mind there. We will see that as we get more and more complicated. So I just did another one for you. Anyway, Johnson, I hope that makes sense. Let me know if that came across coherently. So your job now, before the next class, okay, before we actually do another video on Monday, what I want you to do is spend time on this worksheet. Balance all the reactants, or balance all the reactions if you haven't already, and then also make a little note on the side, just testing yourself if you can decide what kind of reaction it is. And then on Monday, I will go through and I'll balance a few more. I don't want to do all 37 with you because that will make for a very poor video. And then do some more balancing, but I will also go through and tell you what kind each and every one of them are because that only takes a minute. And then we'll start getting more details for each type and we'll go further and further. By the middle of next week, you'll be deciding on what the products are on your own without me giving them to you. So we're just going to give you more info, baby step it. All right. Very good. Thank you guys for checking in. We're up to 5 people who are watching this, and everybody else, I'm assuming you're going to watch this later. So this will stay up on Google Classroom for the foreseeable future, and you can go back and watch this anytime. Monday, more stuff starting with this worksheet. All right. Cool. Thanks for checking in, and I'll see you guys on Monday. Thanks.